My comment section has been begging me to try out the new adaptive frame gen mode in Lossless Scaling. This is like a $6 or $7 app on Steam, so not a massive investment. So we're doing that now. And also, before I turn it on, what hardware are we using? So I thought, let's try this out on the 3090 Ti because it's the most powerful, like $2,000 GPU NVIDIA released to not officially support NVIDIA frame generation. Which means that if I'm playing a game like Cyberpunk and I want to kick on, I'm at 1440p, I want to kick on path tracing, I can do that. And using the transformer model of DLSS and ray reconstruction, I can get a reasonable frame rate with the quality level upscaling. Here you can see we're, around 49, 50 FPS. We could maybe go a little more aggressive on the upscale, but let's start here. Let's see if Lossless Scaling can save the day, because if I wanted to kick on frame generation in Cyberpunk, I would have to go into FSR 3 frame generation. Not that that's necessarily in itself a problem, but it switches me into the FSR pathway for upscaling as well, because this isn't the 3.1 update, which allowed those to be decoupled. So I would have to lose out on the nice ray reconstruction and DLSS transformer model, which I don't want to do if I want to use the game's inbuilt FSR frame generation. So that's the scenario I've set up for us to start testing. Perhaps we can test out other GPUs and all sorts of things. I've even heard you can run on a secondary GPU. Cool stuff. Let's go ahead and kick this on, but first, some of you are making a huge mistake when upgrading your gaming PC setup, and that is not thinking enough about the chair you will be sitting in the entire time you're using the PC. What you need is a high-quality ergonomic office chair like the Hibata P2 that Hibata recently sent me, and huge thanks to Hibata for sponsoring this part of today's video. Your back will thank you so much for upgrading to a Hibata ergonomic office chair, and the P2 has all the features you need. A mesh seat and back solves those sweaty long gaming sessions, and adjustable height armrests solves the annoying problem where you get a chair that can't actually sit flush with your desk or reach an appropriate height for reaching your mouse and keyboard comfortably. The Hibata P2 armrests can move forward, backward, up, down, and even swivel to get you into perfect position. There's also adjustable lumbar support, which your back will thank you for, and an adjustable headrest, which is even removable, which is great for me when I'm filming on my green screen and don't want it in the way, versus when I need maximum comfort and support when editing videos for hours. Check out the sponsored link in the video description or pinned comment to upgrade to Hibata Ergonomic Office Chair today. Your back will thank you. All right, let's kick on the frame gen. Now, one thing that's important to know, why am I saying 119.94? I'm recording this on a capture card. Now, YouTube is a 60 FPS experience. The capture card I'm doing can go up to 1440p and apparently not 120. It goes to 119.94. So I'm gonna try to hit the native, basically native refresh rate of my screen, which is this capture card here. And we're gonna just go into adaptive mode and type in the target frame rate. If you could type in whatever your monitor's frame rate is, and we're gonna go ahead and see what happens. We're gonna leave everything at default at first. Just click scale. It's gonna count down 5, 4, 3, 2, 1. I'm gonna pan back and forth and see if we can see it kick in. Wow, I instantly see when it kicks in. The camera panning, and again, you're watching a 60 FPS YouTube video, so this will probably look different to you than what I'm seeing in person, but the camera panning got instantly smoother. However, at the same time, I am also feeling like my mouse is kind of heavy. The mouse movements seem slightly delayed from when I'm actually doing them. Now, this can be an issue with any frame generation technique, really, although some are better than others, because it's delaying showing you a frame. It's buffering 2 frames that are actually rendered to then kind of guess what happened in between to show you that. That's how frame generation works, which means if it buffers an extra frame, there's a little bit more of a delay between when you move your mouse and when things happen. The other issue is, what if it guesses wrong? And if you look at my mouse cursor right now, I think I'm not alone in noticing things looking garbly and weird on the mouse cursor and beneath the mouse cursor. Also just kind of all the HUD elements and things like that. So I will say, my initial impression here, now we are coming from a fairly low base frame rate, is that while the fluidity is there, this is clearly generating the frames. And by the way, notice my frame rate counter is now down in the upper 30s, but look at this. This is Lossless Scaling's own overlay it kicked on, which is saying the input frame rate and the output frame rate. So it is saying we're outputting 120 successfully, and it does look like 120 in terms of fluidity. But the in-game frame rate has actually gotten worse, not better. That's another thing lending to the kind of worse input feeling, because frame generation has an overhead cost. Now, one thing we can maybe try out in this video is running it on a cheaper, older GPU as a frame generation card to see how that goes. Also, apparently you can try to run it on a integrated graphics that might be on your CPU. Now, I think the CPU I have here has weak enough integrated graphics that I doubt that would work, but hey, we could try that out. Another thing we should probably compare this to is a fixed mode frame generation. So far, like AMD and NVIDIA's frame generations only support fixed multiples. AMD is just at a ×2 mode, where basically it takes 2 rendered frames and inserts a generated frame directly in between. What happened in the exact middle between those two? Whereas NVIDIA has gone up to ×3 or ×4 modes, where it just inserts like, okay, here's your 2 real frames, and it guesses what happens kind of at even intervals in between. But that's the max that they'll support. Lossless scaling supported that well before NVIDIA did. However, the quality is not going to be as good as in game integrated frame generation. But let's try the ×2 mode out, just kind of compare to that. So let's go to the ×2 mode. So again, we're at around 50 FPS before it kicks on. Now the overhead has dropped us to about 42, and then it's outputting about 84. So that ends up being what the ×2 mode looks like here. Now, if I kick this on, we're still getting some frame generation artifacts. By the way, it's really important to note you're watching a YouTube video at 60 FPS, which is different than what I'm seeing. The capture rate being different than what you're seeing means both the fluidity and artifacts of what we see will be different. And it's even possible to get screen tearing and things like that, causing issues because of the out-of-sync capture. So I'm gonna try to describe what I'm seeing, and the video feed you'll see will not be a perfect representation of what you'll see in person. Anyway, so I'm noticing that the ×2 mode is actually giving me more in-game frame rate, if that makes sense, because there's a bit of a less overhead to this, whereas the adaptive frame gen mode brought us to even lower input frame rates, basically, because it had a higher overhead. But again, it was also targeting 120 and hitting it versus only getting to about 84 on the ×2 mode. So interesting. Now, I do also think I'm seeing more artifacts in this adaptive mode than I am in the ×2 mode. Now, why would that be happening? And also, why is this such a new thing? Why is this so crazy? So what's so crazy about this adaptive frame gen mode is when you look at how this actually works, and the developer has a little write-up about this on the update, and I asked him a bit in emails as well, is this has basically abandoned the idea of presenting you real frames. Or if we want to not use the terms real and fake, we could say not showing you the actual game rendered frames. So like I said, with the normal ×2 frame gen mode, if we switch over to this, the way that works with both lossless scaling, AMD frame generation, NVIDIA frame generation, is in ×2 mode, like I said, you get 2 frames, it guesses what happened exactly in between, you get more frames presented to your display, but the game doesn't render any faster, it's not more responsive, there's a bit of overhead, there can be artifacts. And the main downside of the lossless scaling version is more artifacting, because it's not built into the game, unlike NVIDIA and AMD's frame generation techniques, where they can have more access to game data, what's a HUD element, what isn't, that kind of thing. But with this adaptive mode, what's so crazy is it abandons the idea of, okay, here's your 2 real frames, we're gonna present those, and we'll show you what happened in between. Instead, what it's doing is it's saying, okay, we're gonna take these 2 real frames, now you're gonna tell us the frame rate you want, and we'll just take your rendered frames and guess what happened at the correct points to line up with your monitor's refresh rate. Meaning, it's completely possible that when we are going into this adaptive mode, that there are no traditionally rendered frames showing up at all, unless they happen to hit at the exact right moment to line up with the monitor's refresh cycle. So this is extremely interesting. This also lines up with some kind of behind the scenes discussions that have been mentioned by, I think, at least AMD's team when they were first developing their frame gen modes in AFMF, was talking about what the future of frame generation could look like. What if frame generation basically just took whatever frames you had and then used it to output your monitor's refresh rate? Exactly. And that's exactly what adaptive frame gen is doing now. Really, I'm gonna be honest, I'm seeing more artifacting here than I would like, to where I don't think this is something I'm gonna be using personally. Now, everybody has different tolerances for, do you value the increased fluidity more than the increased artifacts compared to native bother you, right? I'm definitely on the side of, I find those artifacts incredibly distracting, so I don't think this is for me. We're gonna try upping the base frame rate a bit now to see if that improves it. But I don't think this is really for me. But I think as far as like a look at what the future could be, if this kind of idea was built into NVIDIA or AMD's frame generation that's actually built into the game, so the game had more awareness of what a HUD element is and could separate those out a little bit better, I could see something like this being extremely interesting and potentially being the future of frame generation. Okay, it's looking a little better now. The artifacting is certainly still there, but a lot better than it was. What did I just change? I changed the base frame rate. Let's go ahead and turn off lossless scaling for a second to get an idea. So I just adjusted my in-game resolution scaling to performance mode DLSS instead of quality mode DLSS. That means the upscaling algorithm has more work to do, so we could potentially see more upscaling artifacting, but honestly, the new transformer model with DLSS looks pretty dang good. Even when pushed into performance mode. Might not love it at 1440p, but I think the artifacts from this are less noticeable than the artifacts we're getting from the lossless frame generation. Now, you can tell that my in-game frame rate is up in the 70s. Again, you're watching a 60 FPS YouTube video. You're not gonna be seeing the fluidity accurately. However, this is where we can then, because we're at this higher base frame rate, then when I go into lossless scaling, when it takes the performance hit, so I'm gonna go ahead and hit that scale button again, we'll see it kick in. First of all, it has more frequent real frames to work with, more frequent actually game rendered frames to work with, which helps it have less guessing to do at what happened in between each frame. Also, the responsiveness of this, I'm feeling is much more acceptable. Again, because now notice that the in-game frame rate is more like in the mid-50s, which is close enough to 60 FPS that that's a more acceptable level of input response for me than when we were dipping all the way down into the 30s. So this is more acceptable to me. The artifacting is less, the responsiveness is better. Again, personal preference-wise, I still think I'm getting a bit more artifacting than I would like, but I could see this being a much more usable experience for a lot of people. I think the next thing I want to check out is the idea that you can run the frame generation on a different GPU than the one you're rendering it on. Because again, if I turn this upscaling off, if I'm actually getting in the 70 FPS range, if I could keep that 70 FPS because we're not going to reduce the GPU headroom, but by then doing the upscaling algorithm work on a different GPU, that would be really cool. Now, the first thing I want to try is the integrated graphics on my CPU. However, my CPU is a 9800X3D, which is an amazing gaming CPU, but the integrated graphics on it is basically not intended to actually do anything graphical other than like output to a display. It doesn't run even the most basic games very well, so I have very low hope that this is gonna work well. That being said, we can set the preferred GPU to the Radeon graphics built into my CPU and go ahead and see what happens. So let's go ahead and click the scale button, give it its 5-second countdown to kick in, and wow, that is, okay, this is interesting. Look at this, look at this. These are the lossless scaling numbers. If you're on a mobile phone, you can pinch to zoom on the YouTube app. Our input frame rate is 60. Our output frame rate is 40. Okay, so I was correct that the mobile GPU is not able to keep up with this. So basically, it's able to generate frames so slowly that it can't even keep up with the native rendering resolution of the game. So let's not do that. Okay, so then I think I'm gonna need to cut here, add another GPU to my system. I'm gonna pull out like my oldest GPU I have. I think I have like a GTX 1060 or something like that. And I'm gonna see if I could use that just as a lossless scaling frame generation GPU We'll see what happens. All right, so ran into a bit of a change of plans. The RTX 3090 Ti system that I was using didn't have enough room around the case at the bottom for the second GPU to fit in. So I figured, you know what, let's scrap that whole PC and do, I think, a more realistic test for a lot of people's setups. This is gonna be an RTX 3060 based PC because I noticed that my Ryzen 5 5600X based system I already had built had a better layout to get a second GPU in there. And so I've also added in the GTX 1060 in the secondary PCIe slot. So this is basically simulating what if somebody upgraded from a 1060 to a 3060 but kept the 1060? Is it useful for actually accomplishing anything? And that's also why you can see in these stat counters here that there are now two GPUs. GPU 2 is the RTX 3060 that's actually running the game. GPU 1 is the 1060, which is currently doing nothing, but the plan is to use that for a lossless scaling GPU. Also, this means that I've had to adjust the graphic settings in the game to something that makes sense. We're still running at 1440p, still on that capture card targeting 119.94 FPS, hertz. And here we've gone with the Ultra Graphics preset, although I have turned off film grain, chromatic aberration, all that stuff. I turned that off in the 3090 Ti test as well, but I've turned off the path tracing mode. That's a bit too much for the 3060 here, especially if we're targeting 1440p output. I'm using balanced mode transformer upscaling. So again, I don't want to use FSR frame generation that's built into the game because then I have to lose out on the nice transformer balanced mode. And it looks like we're able to be around mid 60 FPS range using these settings before enabling the frame generation. So let's go ahead and do it. So I've typed in the 119.94 adaptive mode. Let's go ahead and click scale, except first let's try it out with the GPU being the 3060. Then we'll compare that to using the 1060 to do it. So we should see this kick in just a second here. Whoa, okay, well, it's blacked out for a second, but we seem to be working. Okay, so this took a big load to hit the 120 FPS. It's dropped our in-game frame rate down to in the 40 FPS range, but is then using adaptive to hit about a 120 output. But again, I'm feeling it on the mouse movements and in the, I'm seeing it in the image quality artifacting that there is some latency and image quality artifacting penalty here. Let's go ahead and compare this to what if we set the GPU to the 1060. I have not tried this yet. You're gonna get my actual real reaction here. Let's go ahead and see what happens. So we've got it kicked on. We're gonna, okay, we still had it black out for a second there, but all right, interesting. So we are still hitting the 120 output. Running on that on the 1060, I'm still noticing a lot of image quality artifacting, but the in-game frame rate is higher, meaning because the 3060's rendering things were up in the 50 FPS range rather than dropping lower than that. You can see that the 1060 is going up to like 90 to 100% usage. So that is... honestly, I wasn't sure it was going to be that taxing on the 1060. Maybe I should have tried a more powerful backup GPU. But we do seem to be hitting the 120 FPS output, even if it's fully taxing that that GPU for the rendering there. Very, very interesting stuff. Okay, I got ran over by a car. So my overall thoughts on this experiment, I think, is that it is probably not something I would use personally. I find any little flickering on those HUD elements extremely distracting, which is why I'm even picky about which games I'll use like DLSS 4 frame generation in, even when it's integrated into the game. I still have some games where I'll turn it on, some games where I'll turn it off, just because I am very, very sensitive, I think unusually so, to those types of image quality artifacts. Other people's perceptions and what they find, problematic are completely different. So I think especially in this mode where you have like maybe an old backup GPU that you rely on to run the frame generation on, I mean, that's kind of an interesting experience because then you're, it's not quite so costly on doing the frame generation. So I really think a lot of people could find a useful situation for this. And I think the adaptive mode itself is just a cool proof of concept because like I said, I'm curious if this is the direction that AMD and NVIDIA eventually go, at least as an option. to basically say, hey, whatever your monitor is, we can hit that output. The only question is, what kind of responsiveness and artifacting does it take to get there? And like I said, if we had something that was built directly into games to be more knowledgeable about what is a HUD element and what isn't, I think we would be getting an even better experience here. Interestingly, I think we're potentially seeing some CPU limitations here at this portion of the city trying to hit these frame rates, because I'm not seeing either GPU at a full 100% utilization. Interesting. Anyway, this is just cool stuff. I find this just really fascinating. This idea of, what if we let go of the actual rendered frames and just use them to produce the generated frames to hit whatever frame rate you want? That's a fascinating idea, although currently, like I said, I'm finding the artifacting too much for me personally. Hopefully you guys found the video useful and or interesting. I think this, the app is only $6 or $7. I think it is useful enough and just fun to play around with that I do recommend the app, even if for me, a lot of the frame gen situations don't quite work out. I hope all of you have an excellent day.